In this video, you will learn about equations in two variables. Now up to this point, we've been working with equations in one variable. So equations with one variable will look something like this, where you have 3x minus 2 equals 4. We just have one variable. Or maybe 2 minus a equals 7. We have one variable because it's just one letter. Okay, or maybe even this, where we have x squared plus 6x plus 5 equals 0. This still only has one variable. It's just going to be x. So yes, you see it more than one time, but it only has one unique variable, and that is the letter x. So in this lesson, we're dealing with two variable equations, which might look something like this. 2x minus 5y equals 8, where we have both x and y in the same equation. Or maybe a times b equals 10, where a and b are two different variables. Or maybe a squared plus b squared equals 36, where we have a and b both in the same equation. Now, when working with one variable equations, such as 3x minus 2 equals 4, the solution is going to be a number. All right, just one number is your answer. All right, whereas for an equation with two variables, the solution will be two numbers, or a pair of numbers. For example, if you had 3x plus 4y equals 10 as your equation, negative 2 for x and 4 for y is a solution of the equation. Because if I put a negative 2 in for x and a 4 in for y, we would have 3 times negative 2 plus 4 times 4 equals 10, which is a true statement. Okay, that will make this statement or equation true. So negative 2 and 4 is a solution. When you write your solution, instead of writing it like this, where x equals negative 2 and y equals 4, we can write this as an ordered pair. So we see here, negative 2 comma 4 is how we would write that solution. All right, where negative 2, your x value, will come first, and then the 4, or your y value, will come second. So x comes first, y comes second, just like in the alphabet, right? X comes first in the alphabet, followed by y. Same thing when you write your ordered pair. X comes first, y comes second. So looking at the example where 3x plus y equals 1, we are to determine if these different ordered pairs are a solution to the equation. So to determine that, what I do is I plug these numbers in for x and y. So instead of 3 times x plus y, for the first ordered pair, we would have 3 times 1 plus negative 2, and that's equal to 1. So is this a true statement? Well, we'd have 3 plus negative 2, which is 1. So 1 equals 1. Yes, that is a true solution. Therefore, is a true statement. Therefore, this would be a solution. All right, so this one works. We have a solution. So then the next order pair, we plug that in to determine if this is a solution or not. So instead of 3 times x, we have 3 times 1. And instead of plus y, we have plus negative 4. So we have 3 plus negative 4, which is negative 1. So negative 1 equals 1. That is not a true statement. Therefore, 1 negative 4 is not a solution. And we could do this for 1, 0 and for 0, 1. So we plug a 1 in for x and a 0 for y. We have 3 times 1 plus 0 equals 1. That would be 3 plus 0, which is 3 on the left side. 3 is not equal to 1. That is a false statement. Therefore, 1, 0 is not a solution. One last time for 0, 1. We plug a 0 in for x and a 1 in for y. We now have 3 times 0 plus 1. And on the left side, that would be 0 plus 1, which is 1. So 1 equals 1. That is a true statement. Therefore, 0, 1 is a solution. Now, example 2 is a little bit different than example 1, because in example 1, we were given numbers to plug in for x or for y. And for example 2, we are not given values to plug in. We are instead just given an equation and told to solve this. So here we have x plus 1 times y equals 6, and we are to solve if x and y are whole numbers. Now, when you are trying to figure out what your answers are, it is helpful if you solve the equation for one of the variables. And typically y is the variable that we will solve for. So that is what we're going to do in this equation. So we can solve this for y by getting rid of the x plus 1. Notice x plus 1 is being multiplied by y. So to get rid of it, I can do the opposite, which is divide. So I can divide both sides by x plus 1. When I do that on the left side, the x plus 1's cancel. And on the right side, we have 6 over x plus 1. So I have y equals 6 over x plus 1. And then if you're going to solve this, what you want to do is plug in different numbers for x or for y. And here, since we solve for y, we're going to plug in numbers for x and see which ones will give me a correct solution. So we're going to replace x with whole numbers until we find a solution, because it says our solution for x and y must be whole numbers. Whole numbers start at 0. Okay, so here in this first column are the numbers we're going to plug in for x. Second column is going to be what is y equal to when we plug x in, and then third column will be to determine if it's a solution or not, and if it is a solution, what is it? All right, so whole numbers will start with 0. So plug a 0 in for x and see what happens. So when you plug a 0 in for x, now we have y equals 6 over 0 plus 1. Well, 6 over 0 plus 1 equals 6. All right, so 0, 6 is a solution and it's a whole number. Both are whole numbers, so this would actually work. So 0, 6 would be my solution, where x is 0 and y is 6. Now we plug the next whole number in, which is going to be 1. So plug a 1 in for x. So now we have y equals 6 over 1 plus 1. Well, 1 plus 1 is 2, so 6 over 2 would equal 3. 1 and 3 both are whole numbers, so this would be a solution, where x is 1 and y is 3. Next we can plug a 2 in. So plug a 2 in for x. Now we have 6 over 2 plus 1, which is going to be 6 over 3, which is equal to 2. So x is 2 and y is 2, so my solution is 2, 2. Next we plug a 3 in. So when you plug a 3 in, now we have 6 over 3 plus 1, which is 4. So 6 over 4 is my y value. So technically, this would be a solution where x is 3 and y is 6 over 4, but the instructions say to solve if x and y are whole numbers. So y would be 6 over 4, which is not a whole number. So therefore, this cannot be a solution because the instructions say that it needs to be a whole number. We can plug a 4 in, so now we have 6 over 4 plus 1, which is 6 over 5. So again, y is not a whole number with 6 over 5. So 6 over 5 is not a solution in this particular case because it's not a whole number. And then we can plug a 5 in for x. So plug a 5 in, we now have 6 over 5 plus 1, which would be 6 over 6, which is 1. So x is 5 when y is 1, both of which are whole numbers. So 5 comma 1 would be a solution. And we can keep plugging in numbers, and we would find that after this point, everything would not be a whole number after this. If we plug a 6 in, we'd have 6 over 7. Plug a 7 in, we'd have 6 over 8, and etc. So because nothing else will be whole numbers, these are my only solutions. We have 0, 6, 1, 3, 2, 2, and 5, 1. One more example where now we have actual real-life problems. So here, Grant spent $32 on markers and erasers. The markers were $4 each, and the erasers were $6 each. How many of each did he buy? So here we want to establish what our equation is first. So in this particular example, the equation is not given to us, but we must determine the equation and then solve it after that. So to begin setting up an equation, we would like to define our variables. So to do that, we can let m be number of markers and e be the number of erasers. And then from here, we can create our equation. So we know for the markers is $4 times the number of markers that we buy. All right, so if we take $4 times the number of markers, that gives me the cost of the markers. For the erasers, it is $6 for each one. So we have $6 times the number of erasers, so 6 times E. And if we add that together, then we're going to get 32 as my total. And we see that typed up right here. 4m plus 6e equals 32. Now from this point, we have our equation. Now we need to figure out what our solutions are. So what is m and what is e? So to do this, we want to solve for one of the variables. Now, it doesn't matter which one we solve for, but in this case, let us solve for m. So we're just choosing m just because. So to do this, we need to get rid of the 4 and the 6e. So let's move those to the right side. The 4 is being multiplied, the 6e is being added. I get rid of the 6e first because of reverse order of operations. So I subtract that over to move it to the right side. Now we have 4m equals 32 minus 6e. And then from this point, I can get rid of the 4 by dividing both sides by 4. Now I have m equals 32 minus 6e over 4. And at this point, we can then use this to find our solutions. So here's our little table. E is what we're plugging in. M is equal to 32 minus 6e over 4. So this column will be used to calculate what is m when I plug an e in. And then this third column is going to be my solutions column. So we know that e, the number of erasers, needs to be whole numbers, right? It cannot be a fraction of an eraser. So it's got to be positive and it's got to be a whole number. So let's start with 1 for e. And I guess we could plug a 0 in, but it's not going to work. So we'll start with the 1. Let's plug a 1 in. So now we have m equals 32 minus 6 times 1 over 4. So that would give me 26 over 4, which is not a whole number. Okay, the m, our markers, also needs to be a whole number because we cannot buy a fraction of a marker. So this is not a solution because m is not a whole number when I plug a 1 in. So let's plug a 2 in. Now we have 32 minus 6 times 2 over 4. So plug the 2 in for e. Now we have 32 minus 12 over 4. So 32 minus 12 is 20. 20 over 4 is 5. So this would be a possible solution because erasers is 2, markers are 5. So that is a possibility because both are whole numbers. Let's try plugging a 3 in. Now we have 32 minus 6 times 3 over 4. That's going to give me 14 over 4, which is not a whole number, so this would not work. Plug a 4 in. 32 minus 6 times 4 over 4. That gives me 32 minus 24, which is 8. And 8 over 4 is 2. So this could be a solution where I bought 4 erasers and 2 markers. All right, so that's another solution. We could plug a 5 in. Now we have 32 minus 6 times 5 over 4, which would give me 2 over 4, or 1/2, which is not a whole number. So therefore, this cannot be a solution. So the only possibilities is that Grant either bought 2 erasers and 5 markers, or 4 erasers and 2 markers. And this concludes our lesson for today. We will see you next time.